Hi, welcome back. Once again, I am welcoming you this beautiful online learning platform, Unacademy. Unacademy is the India's largest online learning platform. So, Unacademy is the India's largest online learning platform. Now, we are happy to announce that we are going to yeah. Now, Unacademy is providing online training for GATE and engineering service examinations. By online. And about myself, I G Venkata. I have 16 plus years of teaching experience. So far, I mentored more than 60,000 students for their GATE examination. At present, I am pursuing PhD from JNTU Kakinada and my specialization is in VLSI domain. First, we check how to get Unacademy learning app into our device. Just go to Play Store, type Unacademy in that. You will get the Unacademy learning app like this. Just by clicking on this install button, you can install Unacademy learning app into your device. Now, here your classes are taken care by India's best educators. See that how we are calling these are the best educators. Tiwari sir is the IIT topper. Ankit Goyal sir, he obtained 2 times All India first rank in GATE Electrical. Okay, and he was awarded President of India Gold Medal in IIT Indore. Sanchit Jain sir is a computer science faculty having a teaching experience of more than 8 years. Okay, he has a very sound experience in teaching the students. And JASPAL Singh sir, he is ex-IAS officer. He got All India 4th rank and he is the ex-senior faculty from ADC. Okay, so based on these things, we are claiming that our educators are the top educators. Now here are few more top educators from Unacademy. And yeah, now there is Unacademy comeback is going on. Once again, it is back. So already last week and before last week, 14th, some of you have written the examination. And 21st, some of you have written the examination. And again, March 28th, again one more comeback. Okay, this is for electrical and electronics and communication engineering students, especially for. Now the exam is on 11 a.m. See, just check see this alum. He's got the ECE first rank in 14th March 2021. Now, so he is electrical second rank, ECE third rank, ECE second rank, and electrical third rank. So these are the people are going to getting 100% scholarship. These people only 100% scholarship. Okay, for GATE plus subscription, 100% plus scholarship they got. Okay. Now maybe next you are going to be that one. Okay, don't wait. Please register now itself. Okay, now next is coming Sunday. There is an exam. Okay, scholarship test. Don't miss that. Now, challenging and original questions created by best Unacademy educators. The original questions. What are the expected questions in the GATE examination? That questions are going to be created by our best Unacademy educators. Okay. And every time now it is a super fast and fun with All India live leaderboard. It means once you answer one question, so that question was answered by the remaining people throughout India also. So many number of people in the India. Now, based on your accuracy and the speed, we are going to providing a rank to you, live rank to you throughout India, live rank. Okay, so that is very useful to you to assess your level compared to the other in throughout India. Okay, see, I'm going to solving one problem. Maybe that problem I may solve that problem or not. That is a different issue. Okay, even if I solve the problem, if I take more time to solve that problem, no use of it. My rank is going to be the last level. If I solve the problem within the less time, then only I got the good rank. Because now the competitive exam is basically a game with the time. They are playing game with the time. In semester examinations, to answer one question, you are taking nearly 25 to 30 minutes of time. For example, 25 minutes of time you are taking, let us, to answer a question in semester exam. Now the same question in GATE examination, they will provide only hardly 3 minutes, not more than. Within 3 minutes you have to answer that. See, time game it is completely. If you give a regular time to you, you can solve. Most of the people will solve every question in the GATE examination if they give a time. But within the less time, within that stimulated time, who are going to be solving? That is the criteria here. Okay. So it is simply a time game. So if you want to win that, first you need to check where you are. So that we are going to providing that facility to you. Now take it live. By taking it live, you can know where you are. So where based on your contestants, where you are. Next, identify and improve your weak areas. Improve your weak areas with detailed video solutions. Detailed video solutions are provided to you after completion of every exam. Okay, from that video solutions, there is any gaps in your preparation, or that means if you are weak in that region or in that area, you can improve your knowledge in that weak areas. Now compete, crack and conquer. See, score. Get a scores for your speed and accuracy. For your speed and accuracy, we are providing a score. Okay. Next, leaderboard. Get to know your rank after every combat. That means for every question attempt, you are going to getting your new rank. If you answer one question correct with less time, your rank will be developed. Your rank will be up. You are moving towards up. Okay. Now, rating. Take a combat, get it right and improve your overall rating. Take the combat and improve your rating. Awards. Climb through the ranks. Climb through the ranks and earn badge of honor. We are providing a badge of honor to you. Now, a scholarship of worth 1.8 crores plus in this March. So the next exam is on 28th March, just before what I was mentioned. It is at 11 a.m. Okay, just enroll today itself. Don't waste your time, and don't at the same time don't forget to use my code VIRAV10 during to unlock your test. Okay, so this is my code. So this is my code. This is my code. Don't forget to use my code. This is my code. By using this code, you can unlock it. Okay, after that, by unlocking that, you can enter into the test. Don't forget, it is a worth of 1.8 crores plus. Don't forget. And the exam is on 28th March 2021 at 11 a.m. Now, competition format. See the competition format. 60 minutes of time, 20 questions. 20 into 3 minutes, 60 minutes. 5 different departments: mechanical, civil, electrical, electronics, ECE, electronics and telecommunications, computer science and IT departments. Relative scoring we are providing based on your speed and accuracy. Okay. Now, see here, India's largest weekly scholarship test for GATE we are providing. and assess your gate preparation in 60 minutes. Within 60 minutes, whatever your preparation, you can assess it. And challenging and original gate questions was curated by the best educators are going to be curating. That is the original questions we are providing. And the electrical and EC students are eligible for this. Take it live to compete with the best. Okay, super fast and fun with All India Live Leaderboard. And identify and improve your weak areas through detailed video solutions. Okay. So don't forget to use my code VRAO10 during subscription to unlock it. Okay, register now for free for exam. And see, enroll now in Unacademy Combat just by joining our app. And now there is a engineering service exam 2021 test series is going on. These are the dates for different departments. Okay, dates for different departments. Now for mechanical it is 22nd and 29th March, electrical 23rd and 30th, civil 24th and 31st, for electronics and communication 25th March, general studies on 26th March. In that 10 questions and 20 minutes of time. To unlock it, use my code VRAO10. Now just elevate your engineering service exam 2021 by writing the full length mock test in that 150 questions and 180 minutes of time. The dates are 21st and 28th of March at 10 a.m. for mechanical, electrical, civil and electronic students. And there is a golden opportunity for civil engineering students. Crack engineering service exam with JASPAL SINGH by join us for free test series. The topic wise test series is going on. With the dates 6th, 13th, 20th March, 27th, 3rd April, like this. These are the dates with the JASPAL SINGH. Okay. Now Ultimate 10 SSC series is going on. In that Ultimate 10, we are providing 10 questions to you, 20 minutes of time. These are the dates for 10 a.m. at 10 a.m. for mechanical engineering students. Even after date is completed, if you are attempting on that date at 10 a.m., you can participate online. Otherwise, even after the live test session also you can attempt. Even after live test session also you can attempt the exam. Now the same for electrical engineering, 10 questions, 20 minutes of time. Okay, these are the dates and the timing is at 10 a.m. Okay, even after attempting the test, after the live test session also you can attempt the test. Now we are moving to civil engineering. Same thing, 10 questions, 20 marks. These are the dates. Now we are moving to GATE, quick start your GATE preparation 2020. This is a really golden opportunity to the people who are going to writing the exam. 10 questions, 20 minutes of time for mechanical engineering, electrical, computer science and information technology, civil engineering, ECE and chemical engineering. This test is on every Tuesday, Thursday and Saturday at 10 a.m. Tuesday, Thursday and Saturday at 10 a.m. Okay, so 10 questions, 20 minutes of time. See, this 10 questions weekly 3 times. If you take worst case 4 weeks per month, and if you take like that, if you follow these for 10 months, you get 1200 questions, 1200 models you are getting mostly. 1200 questions, 1200 models. Worst case, if you take 800 to 1000 models, different models you get. By following these models effectively, by preparing these models effectively, you can unlock your test. Okay, you can crack your GATE exam. Okay, so don't forget to use my code during unlock. This is the dates, Tuesday, Thursday and Saturday dates. Don't forget. Now we are happy to announce that recently we started two new batches, one for GATE 2023, other one is for GATE 2022. And the faculty who are handling the subjects in GATE 2023, same faculty are handling the subjects for GATE 2022. So here are the team of faculty who are handling the subjects for mechanical engineering for GATE 2023. It was started from 22nd February 2021. Next, there is a evolve batch for GATE 2022, same mechanical, the same team. It was started from 22nd February. Now there is a mission DDR going on for mechanical engineering students from GATE for GATE 2022. These are the team of faculty in that: Tiwari sir, Umameshwara sir, Meenu Gupta ma'am, and Aman Raj sir. Now we started this batch with the intention that every student in this batch has to get a good rank, top rank in upcoming GATE exam. With that intention, we started this batch. And this batch was started from 22nd February 2021. And there is a Spark batch we are going to start for GATE 2022 for civil engineering students. This is an English batch. Here are the team of faculty who are working under this. Okay, and don't forget the date it was started from, starting from 22nd February 2021. There is a Ascend batch for GATE 2023. Ascend batch for GATE 2023. This is for civil engineering. This batch was started from 8th February 2021. Here are the team of faculty who are working under this. Same faculty are going to handling the subjects for GATE 2022 eval batch. It was started from 8th February. Now, there is an eval batch for computer science and information technology. Here are the team of faculty members who are working under this. It was started from 8th February 2021. Next, there is a Ascend batch for GATE 2023. Here are the team of faculty who are working under this for electrical department. This batch was started from 8th February 2021. Now there is a evolve batch for GATE 2022. Okay, now this batch was started from 1st February 2021, and now we are moving to electronics and communication engineering department. This batch was started from 2023. Sorry, it was started from 1st February for GATE 2023. Last but not least, electronics and communication engineering. Okay, this is a evolve batch for GATE 2022, electronics and communication engineering. Okay, now the same batch who are handled GATE 2023, the same batch is handling GATE 2020. This batch was started from 1st February 2021. Last but not least, now we are moving to chemical engineering. So there is a eval batch for chemical engineering for GATE 2022. It was started from 25th January 2021. So just we glance what are the different engineering disciplines available in Unacademy: electronics and communication engineering, chemical engineering, mechanical, computer science and IT, instrumentation engineering, electrical engineering, civil engineering, production and industrial engineering. Now there are two subscriptions available in Unacademy. One is a plus subscription. So in plus subscription, second one is Iconic plan. In plus and Iconic, India's best educators are handling subjects, and interactive live sessions are there. Best educators handling the subjects, interactive live sessions, structured courses and PDFs, live tests and quizzes. Okay, now here also we get the same thing, but here we are going to show the difference. Whoever the personal coach we are providing to you in Iconic plan, he is going to do the personalized test analysis and provide a proper study planner to you based on this analysis. At the same time, they prepare a study material to you, respect to study material for this study planner. So by following all these things, every student can get a good rank in their examinations. Now plus plan. So this is available at different subscriptions: 1 month subscription, 3 month subscription, 6 month subscription, 12 month subscription, 18 month subscription, and 24 month subscription. For 1 year, it is 30,250. By using my code, it became 10% discount you get. It is became 27,225 rupees only. Okay. Now we are moving to iconic plan. In iconic plan, it is available in one year and 2 year subscription. For 1 year, it is 50,250. For 2 years, 74,000. So by using my code VRAU10 during subscription, you get it by 45,225 rupees only. Okay, and please discuss with your parents, your friends, and your faculty who are having knowledge on GATE and engineering service exam. Take a right decision that should change your life into a beautiful direction. Okay, you should live in a should lie. Okay, you should lead a beautiful life. Okay, now. So thank you. Thanks for spending time. Now our today's topic is MOSFET, and MOSFET construction, operation, everything we completed. Now we are going to taking, this is the channel length modulation concept, already we completed. The basic application of MOSFET is used in the designing of logic gates. In VLSI, the purpose of MOS transistor is used in the designing of a logic gates. Okay, now I am going to designing logic gates by using NMOS transistor at present. Designing logic gates by using MOSFET. By using MOSFET. By using MOSFET. Now, see, the first logic gate is here we considered these are the main gates. First NOT gate, second one is NAND gate, and the last one is NOR gate. These are the basic gates we considered in VLSI. And if you check the operation of MOSFET, that too we are using enhancement only. Enhancement is the basic gate. And one more thing, there is a name called technology. So you can design by these things using NMOS only and using enhancement only also. NMOS only and enhancement only, EMOS only. These are the two options. If you are designing that by using NMOS only, that means in NMOS we have two types, EMOSFET and DMOSFET. EMOS and DMOS, depletion MOSFET. In enhancement we have two options. We have NMOS plus and PMOS. So in the designing of, if you are going to using only NMOS transistor for designing of logic gates, that is called NMOS technology. NMOS technology. And if you are using NMOS and PMOS in the designing of these logic gates, that is called CMOS technology. Complementary MOS technology. Complementary MOS technology. So that means we are going to using both NMOS and PMOS transistors. Okay, now just take a note of this point, slides. Next we are moving to designing of logic gates by using NMOS technology. Okay, now here this is your NMOS transistor. So NMOS transistor is like this. This is the symbol for NMOS enhancement, and this is the symbol for NMOS depletion. This is enhancement, and your depletion MOSFET is like this. So it is thick. Now gate, drain and source terminal. There is an arrow mark on this source. This is NMOS. Both are NMOS transistors. Both are NMOS transistor symbols, but it is EMOS, enhancement MOSFET. This is depletion MOSFET, DMOS. This is DMOS, depletion MOSFET. It is the gate terminal. It is the drain terminal. It is the source terminal. And source terminal, there is an arrow mark. Now you observe one thing here, the gate is thick on depletion MOSFET. The meaning of this thick is gate is implanted at the time of manufacturing. That is the meaning of this thick line. Thick line represents channel is implanted on gate. Below the gate, channel is implanted at the time of manufacturing. That is the meaning of that. Okay, that is the meaning of that. Okay, now so far we know the EMOS and DMOS symbols. Now in EMOS you should know one thing. When gate is high, when voltage at gate, that means VG, voltage at gate is high, means logic point of view, high logic, then EMOS is on state, then EMOS is on state. That's it. That is on state. That's it. Okay. Now in this technology, NMOS technology, depletion MOSFET is going to be used as a resistor. By connecting gate and source short to this, you can be used it as a load. By using connecting those two, you can use that one as a load. Okay, now first I am going to designing NMOS NOT gate or NMOS inverter. First one is NMOS inverter. Now I am going to complete NMOS technology. NMOS technology. NMOS technology. NMOS technology. Okay, now in that first NMOS, not gate, NMOS, not gate or inverter. Okay, now I am taking this symbol. This is the circuit diagram. So properly take the note. Now so this is VDD. Here we are taking input V input, and this is shorted to this. Gate shorted to source. Sorry, here is the source. Shorted to source. From this taking the output. This is a depletion MOSFET. This is enhancement MOSFET. So to represent that is a depletion, I am placing the channel. That's it. This is the NMOS inverter. Here is output, P output. Okay, let us take some name Q to this. See, always it behaves like a load. It behaves like a load. Always it is on state. Always it is on state. Behaves like a load means load resistor. Now, the operation depends on the this MOSFET, enhancement MOSFET. Now, this is input, Q condition, on or off, and output. Let us input is either high logic, that means high voltage or low voltage, or high logic or at low logic. For high logic, once you are applying high logic, just before we studied, if Vg is high, this transistor is on state. So now this Q is going to be on state, and if low it is off state. Once it is on state, what happens is, already it is on state, no doubt at all, it is on state. Once it is on state, current is flowing like this to ground. If it is off state, current is flowing to output. That means your output is connected to VDD if it is off state, otherwise your output is connected to ground. And anyway, to observe one thing, if Q is on state, see carefully, if it is high, Q is on. Once it is on, your output is connected to ground. That means output is low logic. If Q is off, at low condition, Q is off, now your output is connected to VDD. Output is high logic. That's it. Simply, for high input, output is low. For low input, output is high. That's it. There is one drawback in this technology. The drawback is, see carefully, now the drawback is, whatever the transistor Q on, if Q is on, there we can observe there is a static current flow from VDD to ground. Current is flowing. Once there is a static current flow from supply to ground, and this is also you can take it as VSS. We call these two are called power rails. VDD and VSS are called as power rails. Okay, if there is a static current flow between power rails, then there is a more power dissipation in the device. There is a static current flow between the power rails, then more power dissipation is there in that. This is the drawback in that. Now I'm moving to next one, that is a NAND gate. This second one is NAND gate. NAND gate. Simple, everything is same. Now let us take this input is A. Okay, I'm going to copying the same for next. See this? Same thing. Another transistor I'm taking, just connecting in series with this. Connecting in series with this. Now it is grounded. This is our ground or VSS. Now let us take Q1 and Q2. Input is A. Now this is B. Now let us take the check the operation of this. Now A logic, B logic, Q1 status, Q2 status, and output. Simple thing. If output is connected to ground, then output is low logic. If it is not, output is high logic, VDD, because always this depletion MOSFET is on state. And output. Now let us, I am taking A is high. Once A is high, Q1 is on state. Okay, next I am taking high. Next I am taking low. Otherwise I do one thing, I follow the one procedure 0 0 0 1. See, this is our sequence 0 0 0 1 1 0 1 1. I follow that. 0 means low. Let us take A is low and B also low. Once low, both Q1 are on, Q2 are off state. Off state it is also off state. Once both are off state, there is no static current flow, your output is connected to VDD. So output is high. So this is the first one. Second one, 0 1, that means low high. Low high. Okay, for low high, so low means as usual it is off state. It is off state. For high it is on state. Q2 on. Even though Q2 is on, it is off. Because of off of Q1, there is no static current flow between V0 to ground. So no current flow because Q1 is off. So output is again high. Again high. Now I am taking this high low. High low. For high and low, this just it is changing. High low. So now it is on state, it is off state. Now output is again high because there is no static current flow. Now I am taking high, again B also I am taking high. Now this is on state, this is on state, that means there is a static current flow between this because both are on state between this. Now output is connected to ground, so output is low. Now if both A and B are high, then only output is low. This is the case taking place in NAND gate only. So this is the NAND gate. Next we are moving to NOR gate. NOR gate. NOR gate. See this? Whatever the gate you connected here, just connect another gate parallel to this, not more than that. Just take the another gate, connect this one parallel to this. That's it. Now like this, it is connected ground, it is also connected to ground, both are in parallel. So now it is a Q1. Let us take Q1, it is Q2. Now A, B, this is the NOR gate. Now the same way, the way how we solve the process, how we observe the process previously, the same way you can observe the process of this. Clear? Now here also two possibilities. If both A and B both are high, now the current is flowing like this, as well as like this also. So if both the inputs are low, then your current is flowing to output. Okay, this is the NOR gate. And if you want AND gate, for AND gate, just to do one thing. Take, here I will write that. This is NAND gate, fine. For AND gate, take the NAND gate, connect the output of NAND gate to NOT gate. At output you get the AND gate. Similarly here, for getting the OR gate, to get the OR gate, just take the NOR gate output, connect it to the NOT gate, then you get the OR gate. This is your NMOS technology. And now we are moving to CMOS technology. Same thing, whatever the NMOS enhancement transistors we are using, the same way we are going to be connecting the transistors in CMOS also. Okay, now first CMOS technology, complementary MOS transistor technology, CMOS technology. In this, here a group of, based on the number of inputs, n number of inputs, so n number of NMOS transistors and n number of PMOS transistors. A group of NMOS, sorry, here we are using PMOS transistors, here we are using NMOS transistors. Okay, both are number, and a common input we are applying. Inputs for input A here, same input A, input B, like that. Now both are shorted, taking the output here. This is called pull up section, and here we are connecting VDD, here we are connecting to ground or VSS. This is called pull up section because always it try to pull your output to high, and this is called pull down section. It is always try to make output low, that is pull down section. Okay, now we are going to designing one by one. First I am going to CMOS we are discussing. CMOS inverter. CMOS inverter. Simple. One PMOS, another NMOS. That's it. VDD. Here input, here taking output. It is QP, QN. Now there is an arrow mark here. Here is an arrow mark. For this source, gate, drain. For this drain, source, gate. That is the CMOS inverter. Okay. Now the operation is same. Simply operation of QP is opposite to the operation of QN. At any time, only one of the transistors is on state. Okay, if input is high, see this, input QP, QN and output. Now, I am applying high as well as low. Both I am going to apply. For input high, input is high, QP is off state and QN is on state. And for input low, QP is on state and QN is off state. Once QP is on state, your output connected to ground, output connected to VDD. QP on state, QN off state. Only one transistor is on at a time. So output is connected to high. If QN is on state, output connected to ground. So here output is connected to ground, so low, output connected to high, VDD, so it is high. So next I am going to inverter. Inverter is over. Now CMOS NAND gate. Simple. First write the pull down section. In pull down section, two NMOS transistors are in series. Two NMOS are in series. Now here pull up sections should be in parallel. Two PMOS transistors should be in parallel. That is the only difference. VDD. Sorry, it is PMOS. That's it. These are the terminals. Now you can connect the terminals like this. Input A. Input B and taking output from here. B output. Okay, so this is called pull up, pull down section, and it is pull up section. Only that is the difference. Next I am going to CMOS NOR gate. CMOS NOR gate. Simple it is. Now here two MOS transistor NMOS are in series parallel for NOR. Let us take the value AB. Now here these two are series. PMOS transistors are in series. A, it is B. That's it. VDD, taking output from here. That is the CMOS NOR. Let us, I take some logic and we draw the CMOS technology logic for that. Let us, I want this logic. Y is equals to A plus B into C plus D whole bar. I want to realize this. First draw the pull down section. Pull down. A plus B plus, so that means two transistors should be in parallel, and C plus D both are in parallel, and but A plus B and C plus D both are in multiplication here, so both are in series. That means it is like this. So now here it is A, it is B. Next, that means now it represents A plus B, and we need again C plus D, but it is into C plus D whole bar. So here we are taking output. Now this is pull down section. Now pull up section is simply complement of this. Now these two are in series here, and that series and these two are in series. Now this series both are in parallel. So now it is like this. Is VDD. Is, let us take A, take B, C, D. So like this you can design your digital system by using MOS transistors. This is the CMOS technology. Okay, so like this you can design any technology or any logic whatever you want by using NMOS technology and CMOS technology. The same thing here, we are using CMOS. The same thing also you can design by using NMOS. Simple. See this, how I am going to be designing this by using simple NMOS. But NMOS technology is very easy to implement. Okay. Now I want to implement this function. Y is equals to A plus B into C plus D whole bar. This is the function we need to implement by using NMOS technology. NMOS technology. See this. Simple. Here just I am replacing that PMOS structure by depletion MOSFET. That's it. VDD over. This is NMOS technology. So NMOS technology is very simple to design and less number of transistors, but the drawback is high power dissipation. High power dissipation. Whenever there is a static current flow from supply VDD to ground, then it consumes more power. That is the drawback in this. So to solve this drawback to problem, we are switch over from NMOS technology to CMOS technology. Okay, this is about MOS transistors. So next session we are going to the remaining parts, topics. Thank you. Thanks for spending your valuable time with us. Don't forget to use my code VRAO10 during subscription. Please hit the bell icon for getting notifications, and don't forget to subscribe us, and please join our Telegram group for getting latest updates on our upcoming videos. Please give your valuable comments on our YouTube. Thank you very much. Thanks for spending your valuable time with us. Thank you very much.